Hey guys, let's see if we can capture some packets. Let's see if we can see what we were talking about regarding IPv6 multicast address. Let's see if we can capture that in action. What I'm going to do is start a packet capture with Wireshark. I'm going to filter that, as you can see here, just so we can see the package and the messages regarding ICMPv6. It's going to be a little bit difficult. Well, not difficult, but I'm going to have to do some trickery here, if you will, because all I want to, one of the messages that I need to capture, or that we want to see actually in action, is the neighbor solicitation message. That message, the interface sends that message, or the process sends that message out when it's trying to assign itself a linked local address, or any address for that matter. It goes through a process called, as we're reading in my blog, it is called duplicate address detection. So it will put together, in this case, a linked local address using Slack and the modified EUI64 format. Once it does that, it will send a a neighbor solicitation message with that address, in hopes that nobody will reply. If nobody replies, if it doesn't receive a neighbor advertising message back, that means that that address is free to be used. So I'm going to go ahead and start what I did in order to capture that message. That happens at the very beginning. I stopped the Wi-Fi on my laptop. I'm going to start it now. Actually, I should start the capture first. We're not going to see any. We're not going to see any packets because, again, my Wi-Fi is off at the moment. I'm going to start it now, and here we go. I just started my Wi-Fi. The interface came alive, if you will, and it started sending all these goodies that we see here. One thing that I should mention, a couple of things actually. The first thing is that I'm not running IPv6 in my network. It's IPv4 that I'm running, but the interface in my laptop is capable of running IPv6. And as you know, as soon as it's on, it'll assign itself a linked local address and things like that. So it is sending and trying to communicate with other IPv6 nodes out there. It's not going to find any. Therefore, we're not going to see much of a network. I keep saying network. Neighbor advertisement replies for what my interface is sending out, because again, there's no IPv6 devices out there. Another thing that I should mention, well, I can see what I'm going to do is to stop the capture now. Again, we're not going to see much than what we are seeing here. We're going to start seeing duplicates or the same message being sent out. So I'm going to stop it, and we're going to work with what we have here. First thing that we were going to talk about is the Slack stateless address auto configuration. I'm thinking that I should mention also, yeah, because if you try to do this in your own computer and you haven't done what I did, you're not going to have this output. Let me explain a little bit further. Windows, you may or may not know this, or actually you should know this, that Windows like to do things a little bit differently, or at least Microsoft does. So the operating system Windows, in this case Windows 8.1, does not use the EUI64 format. They generate a different linked local address every time the interface comes on. So it doesn't do that. I don't know why they decided to go like that, but like I said, they do things differently. You can, however, do some trickery and modify things in order for the interface in your Windows operating system to actually use the EUI64 format. I'm going to put a link down below in order for you to get to that information if you want to do it in your computer. For now, all you need to know is that if you haven't done that, you're not going to see the EUI64 format here. For those of you that already did it and you are able to see it, you can follow along. As you can see here, the first thing that the interface tries to do is, well, actually it does, creates its own link local address using, in this case, the EUI64 format. I'm going to show you that now. And then sends a neighbor solicitation that you see here, message to a solicited node address that it constructed. I'm also going to show you that. First thing that we should find out is the MAC address of my interface, and it's right here. 5427.1E08 CE30. If we look at the link local address and my interface is trying to assign itself, it's the same, with a couple of differences, and I'm going to point that out now. If we pay attention at the second value here, it is different from the actual value of the MAC address. It is a 4 in my MAC address, it is a 6 here. Remember, during the process of the modify EUI64 format, first thing that it does, it flips the 7-bit. If we were to convert these values in binary, the first 4 bits will be 0, 1, 0, 1. That's a 5. And the second value, actually we should look, oh yes, we should look here in my MAC address. Second value should be a 0, it will be a 0, 1, 0, 0. That's a 4. But because the 7-bit gets flipped, this will no longer be a 0, 1, 0, 0, it will be a 0, 1, 1, 0. And that makes it a 6, as you can see here. And that's a telltale that the seventh bit was flipped. What it does, and the second step, is split the MAC address right in the middle, right here, and inserts right in the middle the value, as you know, FFFE, and we can see that right here. So what we were saying in the blog about the modify EUI64 format, you can see it. You can see that the interface or the process actually did it right here in our demonstration. We've mentioned also that first thing that the interface does when it comes alive is assign itself an IP address, and that it needs to link local address in this case, and that it needs to find out if that address is in fact being used in the network before it assigns it permanently to the interface. So what it does is put together this address like we just talked about, and it sends out a neighbor solicitation message to a solicited node address that it knows that if there's another interface out there with the same last 6 digits of the solicited node address, it will reply back. So what it does is appends to the predefined prefix solicited node, or predefined solicited node prefix actually, which you know is FF02 colon 1 column FF. It appends to that the last 6 digits of the address that it wants to use, and you can see that that is true right here. This is the destination. The prefix, the solicited node prefix, it goes up to here to the second F, and then the last 6 digits corresponds to the last 6 digits on the address that it wants to use. And it sends this message saying, hey, this is the address that I want to use. If you're out there, if somebody's using this address, please reply. And if it gets a reply, it will not use that address. It will reconfigure itself. Another thing that I want to mention, and I want you to notice, is the source. Remember that we also talked about a unspecified address, and the unspecified address was all zeros or simply column, and that's what we see right here. If we look at the Internet Protocol version 6 goodies, we will see that the source address is a column, and the destination address is the solicited node address corresponding or linked to the link local address that it wants to use. Now, let's pay attention to the second packet that it captured. This time is sent already from its own linked local address. As you can see here, there are no other packets. Nobody replied, so it knows that this address can be used. It assigns it to the interface. Next thing that it does is, I want to know what is my default gateway, what routers are out there. Send me information. That's why it sends from its own address, linked local address, it sends out a router solicitation message, and notice the destination, FF02:2. Remember, that is the old router's multicast address. So far that makes very good sense. The third packet that we see here, this is regarding MLD. MLD, it's not. I don't think it even is a CNCMP. It is definitely not a CCNA topic. I don't even think it's a CNCMP topic. I'm not sure about that. I think it's a CCIE topic. It might be a CCMP topic. I'm not sure. But we are not going to talk about MLD. I'm just going to say that is what a protocol that is used to listen to whoever is joining the multicast groups, who are listening to this multicast groups or addresses. That's what it does. And I'm going to move on to the next packet. We do know what this packet is. Let's recap. First, try to find out if somebody was using this address. Nobody was using this address, so it assigned it to itself. Now it's sending messages from its own address, linked local address, in this case to the old routers multicast group, just to find out if a router is out there, and it will be able to provide them with the IPv6 addressing. Like, for example, if the network was using a unicast address or a global unicast address, the information will be distributed, if you will, by that router with a router advertisement message back. That didn't happen because, again, remember that I said that I'm not running IPv6 in my network, so there's no router out there running IPv6. Therefore, there was no reply. We already talked about this, and now this packet right here we're going to talk about. Now, what the interface is saying is basically advertising itself to any other IPv6 hosts out there. It is sending a message from its own linked local address to the old nodes IPv6 multicast address of FF02:1 with the information saying, hey, is anybody out there? Am I alone here, or is there anybody else speaking IPv6 with me? And that is basically it. That covers everything that we talked about before. Actually, in our blog, the messages are going to keep repeating every now and then. We basically going to be seeing router solicitation messages sent from my interface, trying to communicate with the router. That, of course, is not gonna find, because, again, I'm not running IPv6. I'm gonna recap one more time just to make sure everybody understood. We talked about unspecified addresses, IPv6 addresses, and we see it right here because it doesn't have an address yet assigned, so it cannot say, hey, I'm sending them this message from this address. I don't have an address yet. I'm trying to see if I can use this address. So what I'm going to use is the unspecified IPv6 address. In order for me to find out, or for the interface to find out if I can use, or if it can use that IPv6 linked local address, it constructed using the Slack and the modify EUI64 method or format, actually. And because it knows the rules about solicited node addressing, it put together a solicited node address linked to the address, the linked local address that it wants to use, by appending the last 6 digits of the address that it wants to use to the predefined solicited node prefix of FF02:1:FF. It sent that message out because nobody replied, meaning that nobody was using that address. It assigned it definitely or permanently actually to itself, to the interface, as we see here. Now it's sending messages and it's saying, hey, I'm sending these messages from my from this address. This is my address right here. And it sends it out. In this case, it sends a router solicitation message asking or trying to find out if there's another router on the network or a router on the network that will be able to provide them with the interface with more IPv6 information. For example, a unique local address or a global unicast address. It sends this message, router solicitation message, to the all routers multicast group of FF02:2. We already mentioned what this is, and then it sends a advertisement of its own. It's advertising himself. The interface is doing this from its own address to the all nodes multicast address of FF02:1. And basically that covers everything we were talking about in the blog regarding multicast addresses. Thank you very much for watching.